The New York Times had an opinion piece today that said just because you test positive for antibodies doesn't mean you have them. And it goes on to explain a scenario that's not that impossible, actually, where 70% of positive tests are actually false positives. The article didn't really explain the math, though, so I'm going to try to do that here. So I'm going to start with the assumption that the article made, which is not a crazy assumption. In fact, it's a conservative assumption that 5% of people in the United States have had the virus so far. So here's 200 people, and I have marked 10 out of the 200, which is 5%, in red to show that they have the virus. Now, the article also supposes that testing is 90% accurate and 10% inaccurate. So I'll use that number, and I'm going to highlight positive tests. So for example, among the 10 people in red that actually had the virus, 90% accuracy means that 9 of them got positive tests as well. 10%, or just 1 out of the 10, had the virus but got a false negative. Of all the people who didn't have the virus, those 190 people, well, 10% would get positive results, false positive results, in fact, and the other 171 would actually have correct tests that say that they were negative for the antibody. So now you have a situation here where you have not just 9 people getting positive tests because they have the virus, but 19 people getting positive tests because the test was inaccurate. Put that together into a probability. Among all the people with positive tests, those 28 people, the probability of no virus, you do a part over whole, that probability is going to be the number of positive tests with no virus, those 19, divided by the total 28 with positive tests. And if you do that number, it comes out to be about 68%. I rounded it to 70% because that's what the article said, and also because of significant figures here. Now, that article did make an assumption. It assumed that the test was only 90% accurate, but actually tests don't have one accuracy rate for positive tests and for negative tests. There's actually a couple different rates that they would have depending on how the test was made and how accurate it is in the different ways. So that was a little bit of an oversimplification by the article. And in fact, some of the tests are actually doing quite well in some regards, but not as well in other regards. So the article does give us a sense that we have to be careful about reading into positive tests, that we might be getting positive tests even though we've never had the virus and don't have antibodies. And that's true.